Hi there. My name is Gary Downey, and I'm speaking to you from Curitiba at the meeting of TechSoc and Estudos CTS, where some very interesting material is taking place. I was invited here to give an address at the opening of the meeting, and I titled my lecture, "What is STS or CTS for?" What are STS or CTS scholars for? And the subtitle that I gave was Big STS. The subtitle I wish I had given would be critical participation. Last Saturday, I took office as the president of the Society for Social Studies of Science, known as 4S. And at that meeting, I announced that the theme of my presidency is critical participation. And I would like to take a few moments to tell you a bit more about how I understand critical participation and how it might help you in your own work. And I invite you to contact me if you'd like to tell me about your own work, and perhaps we could interact a bit more.
So, I would like to hear from you, what can we do as researchers?
Okay. So, STS as a field, as a discipline, or CTS as a field or discipline, grew and gained legitimacy by developing critiques of the linear model of knowledge creation, utilization, diffusion rather, and utilization. And yet, if you attend meetings, or you read materials, or you participate in STS, or CTS, what we value, what we perform, what we celebrate, is precisely the linear model of knowledge creation, diffusion, and utilization. Now, as STS or CTS scholars, we do far more. We participate in a variety of arenas that go beyond the work of research, writing, and publication. But that work has much less visibility. It is often devalued, or in my judgment, undervalued. And I have made critical participation my theme as president of 4S in order to increase the visibility that we give to the work of the practice of critical participation, and indeed to expand the work of our organizations so that those organizations map more completely across the work that we STS or CTS scholars actually do. Now, the work of critique is very important. It's essential. And I mean, to put it all too cryptically or too briefly, critical analysis in STS begins by identifying how some dominant images of science and or technology and or medicine and or engineering operate in some particular context. And so it might be some simplistic image of technology or technological determinism or of science as a site only of discovery. And what we do through our critical analysis is we make visible what is hidden by that. And so a great deal of the work that you see across this interdisciplinary, transnational field involves localized situated work making visible what is hidden by the dominant images that operate in those contexts. And then the next step becomes publication, in which we produce an analysis that includes the descriptive accounts that we have formulated, along with some theoretical contribution. And at the top of our hierarchy of theoretical contributions lie what I call compound words, such as technoscience, technopolitical, and so on. And what we value all too much, or what we seek to achieve all too much, is to formulate that critical compound word and be associated with it, because that becomes a crucial step in career development. Now, for me, critical participation involves going beyond, going beyond the work of critique to actively participate in the process, the intended process, of scaling up one's, the images that one nominates through one's research, to helping them scale up to become realities, or to become, as I was saying in my lecture here, following Gramsci, to become life. And the challenge is to formulate our analyses in ways that work for our audiences. And so it modifies our critical practices slightly by shifting them towards a recognition of what is dominant in the arena in which we are studying, and then formulating our analyses so that those who participate in those arenas understand both that something novel is being communicated and that they are being challenged to become critical analysts of themselves. Now, what does all this mean for me, for you? In my case, it has been about engineering. In the States, but elsewhere, the dominant image of engineering learning involves mastering the engineering sciences and engineering problem solving. One learns a method that it's commonly described in the States as a 5-step method. Students will solve thousands of problems during the course of their undergraduate careers, and all of these problems begin with the word given. So a homework assignment in engineering starts with a given set of conditions, and then one is asked to find a solution. And in the process of finding a solution, one has to identify the appropriate equations, formulate a free body diagram, and then apply the equations, conduct the proper calculation, concluding with a solution. And this practice of engineering problem solving fits a larger model that engineers attribute to themselves, which is that they have jurisdiction over technological development. So technological development consists of the appropriate application, selection of equations, the appropriate engineering sciences applied ultimately to technological design. Now, in the process, learning engineering problem solving can have the effect of predisposing this problem solver to divide the world into two parts, because, namely the right and the wrong. If you spend all of your time solving hundreds, if not thousands of problems, and you learn that they are either right or wrong, over time a sense develops that through your work you're going to produce either correct or incorrect solutions. And then you're finished, and you go off into the world. You go to work as an engineer, and suddenly you're sitting beside engineers who are trained differently than you. You are suddenly sitting beside other people from other fields who have different kinds of expertise. And you are suddenly put in a team and asked to figure out how to define problems working with others. Well, the core of engineering education has not trained you to engage in collaborative problem definition with other people. So, my work of critical participation, and this is what I'm recommending that you do for yourself in your local context, involves first sorting out from the points of view of different actors who are in this local situation, what are the dominant images that are operational, and how are they functioning? How are they operating? And then, through your critical analysis, figure out what are they hiding. And then the step of critical participation involves formulating an analysis that might have meaning for them, but also has quality scholarly content from an STS point of view. And this is the trick. It is not easy to do both at the same time. My strategy, the thing that I'm working on now, involves attempting to scale up a different definition of engineering. From engineering as problem solving that leads to technological design, to engineering as collaborative problem definition and solution. To that extent then, as engineers are going through their curricula, for example, and they're learning the engineering sciences, they are not building a pyramid of knowledge that produces some unitary whole called, let's say, the mechanical engineer. Rather, they are learning a variety of sciences and gaining other kinds of knowledge or expertise from other fields, producing unique configurations. So those people who graduate in mechanical engineering are not all the same as the original model might indicate. They are very different from one another with different configurations of abilities. So they themselves are already internally diverse. What I do through a course experience is to offer a methodology for collaborative problem definition that's built around the words and the practices called location, knowledge, and desire. That when students emerge from this course, it enables them to rethink what they're gaining in the engineering sciences, and they leave hopefully better prepared to work effectively with people who define problems differently than they do. What is the methodology of location, knowledge, and desire? It involves first asking, how is this person located? Was this person trained in a different country? And if I've learned a little bit about engineering from different countries, I can start to ask some more intelligent questions. But this might also be a non-engineer. How is this person located? Also, it might be within an organization. How is this person located relative to me? Knowledge or expertise. What does this person know? Rather than assuming that the world is divided into two parts, those who know and those who don't, the students emerge with the assumption that everybody knows something, including, let's say, someone working on the floor of a manufacturing environment. What do they know? And so you have to go and find out. And then finally, desire. What do they want? What are they looking for? So that when you sit down around a table engaging in this practices of teamwork, which are celebrated all the time now and integrated into engineering education, when you're sitting and working with people in a teamwork situation, your focus is not on yourself. Your focus is not on demonstrating to them that you have the capacity to run this group. Rather, your focus is on everybody else. What do they know? How are they located? Where do they come from? What do they know? And what do they want? So this is an example of an attempt at participating critically in worlds of engineering education. And it's working to some extent in some arenas and less so in others. So it's not an easy thing to accomplish. What I would ask you to do, let us say you're interested in small hydroelectric plants. And you are in a location in which the predisposition is to build large hydroelectric plants. And it is assumed that if you build an hydroelectric plant, that hydroelectric plant must be a certain level of megawattage. And I don't know well how the wattage production of hydroelectric plants, but let us say, I don't know, 200 or 300 megawatts. Well, a 200 or 300 megawatt plant in this location might require a fairly large area to be submerged underwater. And hence the implications, the benefits gained from providing electricity to the area at maybe a lower cost than something that would be distributed along long distance is a good thing. But what about all the people who are losing land? Might it be more effective to produce along this river, since we're going to dam up a river, might it be more effective to install instead a series of small hydroelectric plants, each of which would have a smaller head in comparison with the large one. Maybe the total square, let's say square miles or square kilometers covered by this, the water area, the lakes that are now created, might even exceed the actual the lake that would be created by the large dam. But the distribution of that coverage might be such that the actual implications for those who are involved, those who may be displaced, could be quite different. So then the question becomes, the challenge to the STS or CTS researcher is to figure out how those who are involved in dam construction understand a dam. What is the meaning of a dam from the point of view of engineers, from the points of view of government officials, from the points of view of both the electrical producers, the consumers, the producers of generators who might like large generators versus small generators. And then after figuring out what are the dominant images that live in among those actors, to do the critical analysis of what's hidden by those, and then to continue the critique in a direction that's slightly different than telling them, look, people, your technical decisions have social dimensions. You are doing socio-technical work. Don't you understand? Or what is too often the case, and I know this because I've performed this myself, you can't walk into this arena and say this is, your technological work has sociological dimensions. It's much more complex than simple technological design. Rather, the challenge that I'm posing with the concept of and practice of critical participation is to figure out what words they are currently using in the same way that I described engineering problem solving. And how can you extend those words? How can you elaborate those words? How can you add, you're going to put in actor network theory, how can you add one new entity that reorganizes the other entities? In my case with engineering problem solving, when I talk to engineers about problem definition, they say, oh, okay, that sounds reasonable, because problem definition is upstream of problem solving and doesn't sound completely alien. They don't have to abandon their identities as engineers, as engineering problem solvers, to accept problem definition. Likewise, in the case of the construction of hydroelectric dams, what are the categories that are operable among those whose careers are invested in large dam production. How can those categories, and I don't know what these are because I haven't studied them, but how can those categories be adjusted? Or how can one introduce an entity or come up with nominate an idea and then promote it in this arena that has people starting to think a little bit differently about their work? It is, in fact, teaching them that technological work has social dimensions, but to simply say that doesn't give them any guidance. So it requires one to be more specific. It requires one to be more localized. It requires one to be more situated, working with the very specific people that are involved. And the effects of critical participation can feel small, can feel maybe insignificant. But my view is if we scale up critical participation as an STS practice, if we scale it up as something that we celebrate or we devote significant attention to at our meetings, so that we have sections of journals devoted to critical participation, or that we have sections of meetings devoted to building STS or to practices of critical participation, then we as individuals will see that there are other people doing work like us, and we no longer feel small. Rather, we feel part of a distributed community. And for me, that becomes the means, the pathway for STS to move from this small field that's widely distributed. I mean, STS has reached many elite spaces, but in every space that I have visited or spoken at, STS programs tend to be located in relatively marginal spaces with relatively small numbers of faculty and small numbers of students. My view is that given the ubiquity of technology, the ubiquity of technological experiences, there is absolutely no upper limit on how big STS should be. CTS. In every location where we have technological developments, we should have STS people there. So I look at a meeting, the 4S. I'm now president of the Society for Social Studies of Science. We are very happy that just recently, a week ago, less than a week ago, we had the largest ever meeting, a solitary meeting that wasn't a joint meeting, somewhere between 1,100 and 1,200 people. This is quite exciting for us because many of us who have been around for a while remember the days when we had 200 or 300. In my judgment, this is just the beginning. Our numbers should be 10 times that. Our numbers should be 100 times that. I'm an idealist, I'm sorry. But what that means then, and what integrating critical participation into our work means, is that the functioning and practice of an STS scholar is about more than doing research and publication or reproducing the linear model whose critique justifies our very existence. It means multiplying, and it means adding new identities and accepting those identities as legitimate. Even if in the short run it might be at the sacrifice of desired status in one way or another. I hope that was helpful to you. It's a shorthand of shorthand version of a presentation that I just gave at this wonderful meeting. I hope to be able to make that entire lecture available to you at my own website. So if you find these ideas, the idea of critical participation, to resonate, to fit your desires, and I think it does, because I think most people come to STS with some with some sense of passion, with some some body of technical knowledge, some arena of technical interest, but then this passion to do something more, and this is especially true among graduate students and younger faculty. So I'm taking it, making it my theme, my mission, which it has been for most of my career. My students know this, but now I have this official role. It is, I'm trying to grant this great visibility across the STS CTS community at large, in the United States, in Europe, in East Asia, and now in Latin America. Thanks a lot for listening. I appreciate your time, and go do good work.